Okay, so we were talking over last night's homework, and I felt like I didn't explain that well enough. I'm explaining it one last time. You make a number line. You should know that because I did give you the tip that whenever you see that less than sign, it's like the end of a number line. Okay? The number line is a hint that you have a range of answers that work. The things that don't work are -2 because that's going to make it crash, and that's undefined. And then the thing that makes it 0 is the other thing. I was saying these words here, but I think it's easier to say what makes it crash. That's the same as the vertical asymptotes. And what makes it equal 0? That's the same as the x-intercepts, because x-intercepts are zeros. It all comes together. All right, so then this spot actually works because it's a 0 and it says or equal to 0. And then we test it in here and it works, and you test this spot and you test that spot and you see if it works in one of the two places. All right. So long story short, you need to test for zeros and for asymptotes, or the thing that makes it crash and the thing that makes it equal 0. Then I just was about to stretch them when I started the video here to say, what if this was an 8? Now everything changes because it's not equal to 0 anymore. So all I got to do is set it equal to 0. Would everybody please write this one down, subtract 8 from both sides, and then you'll notice that you need to find a common denominator. This will involve significant writing. So it's x minus 3 over x plus 2 minus 8, and I'm going to put that over 1, is less than or equal to 0. Now I got it set equal to 0. That's a good thing. But I need a common denominator. Mr. G in the back row. What would be a good denominator for these guys? I agree. So what should I do to make that happen? To have an x plus 2 as a common denominator? Awesome. Now really, what I'm trying to do here is make this all into one equation. The bottom of which I got to make sure I know what will make it crash. You know what? It's still going to be -2 is going to make it crash. But when I change the problem to say 8, I changed especially the thing that makes it equal 0. Do you get, I got to make this little equation right there equal 0. So now I got to say x minus 3 minus 8 times x plus 2 equals 0. That just looks like a little algebra equation. I can solve it. I figure out what makes x equal 0. And then what was all that work for? So that I could figure out what the other number is on the number line. The thing that crashes the denominator is still a -2. So that's still poison. Not going to work. U, undefined. And then I solve this little equation and I figure out what the other thing is. That's an important point. So let's solve this. X minus 3 minus 8x, careful with distributing this, minus 16 equals 0. And the -8 and the positive 1x makes -7x minus 19 equals 0. -7 equals x equals positive 19. So final answer 19 and over -7, or -19/7. Whew, ick. But I really don't even have to know what that decimal is. All I need to know is which side of 2 is it? Is that bigger than 2 or less than 2? Because it's like -14/7 and then another 5 more. So it's -2 and 5/7. So yeah, it's in here. So this spot, -19/7, is an important spot. And now I test on this side. I test in between the 2 circles, and I test down here, and I see where it works. Okay, that's what today's homework is like. Everybody arrow to today's homework right there. You see how it doesn't say less than or equal to 0? It says less than or equal to 1. So the very first thing you do before you don't even start the problem until you have subtracted 1 from both sides. And then I'll have 3x minus 1 over x squared plus 1 minus 1 is less than or equal to 0. Now this 1 has to be changed to 1 over 1, and now it's got a denominator, and now you get a common denominator by multiplying by something. And why are we doing all of this work? Because we are trying to get it to be one big fraction so that whatever makes the top part 0 is an important thing on my number line, and whatever makes the bottom part 0 is another important thing on my number line. What's the catch on that? It can't be, you can't make the bottom 0. So there is no number for that. But there will be a number that makes the top equal 0. So whatever that is, that'll be a 0. And that means it will work because it says we're equal to 0. And then you just test on both sides of it. Maybe it works everywhere. Maybe it only works less than whatever this mystery number is. All right, that's the idea. And I don't think you need too many of those. We are going to cross off problems 17 and 18. Everybody please do that. Would you please turn your iPad my way right now? Okay, just making sure I know who's with me and who's not. Thank you. All right, and now move on to this page where we have 2 word problems. I will tell you this next test is all about the word problems. Okay, that's the main thing. I mean, granted, we did talk about horizontal asymptotes, Bob, you know, remember Bob, Zob, Bot, that kind of stuff. Vertical asymptotes. You already knew how to find x-intercepts because the x-intercepts are where what? Y equals 0. And to find a y-intercepts, you get x equal to 0. Okay. And if you're doing a quadratic, like a few little sayings I have for you, if you can factor it, you should. And if you can't factor, quadratic formula. All right, good. So that's to find the roots, the zeros, the x-intercepts. All right. And then word problems. Word problems are a big topic. We started that. Remember on our last test, we had that one about the 3-dimensional box. And my strategy for these, for word problems in general, and you're doing both of these, 29 and 32, my strategy for those is to draw a picture and then write the pure form of the formula. We're going to practice that in a minute. And then the last thing is this, which is number 33. It's just writing out an equation using these complicated sounding words. And I will let you, if you know there's going to be some kind of a number involved besides the variables, obviously there's a t involved, and there's obviously a v involved, and it can't be as simple as t equals v, is it? Unless the equation actually says the temperature is the volume. That doesn't make any sense, right? So it can't be that simple. So what if you know there's a constant involved? You can use the letter k for constants. That's kind of a standard math thing. If you throw in a k, you're saying that there is some constant you don't know, but it's a constant, like a number. Okay, so if it's directly proportional to this, seems to me like there should be some constant involved, and there should be volume, of course, involved, and I'll let you figure out how you think the equation should look. It's not don't overthink these. All right. Next one. Frequency of a wave is inversely proportional. Ooh, inversely proportional. That's different, isn't it? What does it make you think when you think inverse? Oh, yeah, some kind of dividing must be involved. Okay. And obviously we have f and we have, is this lambda? Okay, we have f and we have lambda, and it can't just be as simple as f equals lambda, but it's something not too far from that. And yes, there's some other number involved, which you can call k. All right, so you're just writing simple little equations for this. And actually that is the last of your assignment for today is that. Okay, so if it was that simple and I just gave you time to work on it, you would obviously all finish your homework before you leave and be incredibly bored. And I need you to practice word problems. So we're going to do Clash of Clans now. Here is a set of word problems. Okay, and you're going to be in a group which I will choose for you in a moment. And that little group will try to solve these problems together. They're going to involve drawing pictures. I'd like to do one with you before we start with groups. Okay, so everybody get a blank notability doc or just find a room on that same notes where you were. And let's just do one more. It'll remind you of a couple important formulas to do this one I'm about to do with you. The first thought is, if you have a can, we have a can lab coming up, and this will be good prep for that. If you have a can, do you get that there's certain formulas that go with cylinders like these? Okay, so obviously you can't just say pi r squared. That's a circle. This isn't just a circle. Does it have circles involved? Yes. Okay, so give me a formula that goes with a can. You know any? What? That's not a formula. That's close. There you go. Volume equals pi r squared, which is the base, times h. Awesome. Okay, that's one formula that goes with a can. Give me another one. Yes? Surface area of a can. I agree, it's a good one. Can you pull it off? Would you agree there's two of those? And therefore?
4 pi r.
You're warm.
Oh, well, 2 pi r times height.
Okay, just hold on one second. Start with that. What is? There you go. Pi r squared times 2. I'm going to choose to put the 2 in front. Awesome. That's the two circles on the can. I want you all to just think about an exploded can for a minute. Here's the top of the can. Here's the part of the can that you can peel away, and here's the bottom part of the can. We already got our two circles. The other thing is obviously just a rectangle. But think about the rest of it. What would this part have to be? What would this part have to be? Come on, you can do this. Hands down. I want to call on a random person. 4 or 5 people know. But everybody needs to think this through. I'll give you this hint. This right here, this length right here, is a length you know related to the radius or the diameter, or I guess that would give you the circumference of the circles involved. Go 5-person 1. Oh wait, over here. Sorry, right here. You did the first part. Oh, it wants you to answer the rest.
So
tell me something you know about it.
2 pi r would be the perimeter.
2 pi r is this distance around here. Agreed.
And so that would be if the rectangle wraps around that. That would be the width of the rectangle.
Yeah. So this green line right here would be 2 pi r. Awesome. How about the other one? That's just the height of the can. So therefore, what's the rest of the formula? Surface area is 2 pi r squared.
2 pi r.
Yes. Well thought out. Okay. This is the 2 pi r right here. And that is the h. All right. So now you've got the surface area of a can, you got the volume of a can. Now, I want you to draw a can and label it based on what I'm about to tell you. This particular can is 3 times as tall as its radius. 3 times as tall as its radius. Figure out its radius, and then you go, okay, 3 times that. It's actually pretty close to this can I have in my hand here. Take the radius is like this, and then I say it's 3 times as tall as that. That's pretty close to this. It's a good question. All I've told you right now is to draw a picture and label it where the can's 3 times as tall as its radius. All right, then here's the last part. You always start with the pure form of a formula. I'm going to choose to talk about surface area in this problem. The surface area of this can, give me your best estimates and I'll average them. How many little square centimeters, you know how big a centimeter is, right? Okay. A square, how many square centimeters do you think would be on this can? Total, around the whole thing. Nope, that's cubic centimeters. Little squares. Like if I had a little cloth piece of, that it was a square centimeter, one by one, how many little centimeters do you think there would be on here? The can I hold in my hands. There isn't really a wrong answer because nobody knows. Give me your best guess. I'll tell you it's larger than 3, and it's less than 1 million.
Do we know
come up with what you think. We can actually measure it and later figure out who's right, but what's your best guess? Everybody write down a number on your iPad that you think would be how many little squares. They would be about the size of your pinky fingernail. That is about a square centimeter, unless somebody has a ridiculously long pinky fingernail. That's about a square centimeter. How many little pinky fingernails would it take to cover this thing? If they're squares, it's got to be area. Write a number on your iPad, and then we will do a quick, I'll kind of try to average them in my head really quick. Centimeters, little squares. I would say they're about the size of your pinky fingernail. This can I hold in my hands? No, this can I hold in my hands. Because I said this can was a lot like that with the 3 R's. This is R, this is 3 R's. All right. All right, let's see your opinions. All right, I have a humongous range. It is true that it's one of those things people are not very good at, like, estimating things. This is why I think it's a good idea to have things memorized, like, for instance, an acre. You guys have heard of an acre before, right? You hear a farmer who has, farms this 100 acres. Well, what's an acre? I've told my kids before. Any of my kids remember this? An acre's a what? A rod is about the length of a canoe. It's 16 feet, and that's what you use for length of portages in the boundary waters. But this thing I was just telling you, the acre one, that's an example. You guys should have something in your head that's the size of an acre. I'll give you one really simple, about a football field. You all seen a football field before, right? Just the stuff that's between the lines on the football field, that's about an acre. Okay, so now you know if you live on 1 acre, it's about the size of a football field. Most people don't. Most people live on about a half an acre or less. In the small city lots, they might be like a 0.2 of an acre, but usually in this neighborhood, there's houses that are all different sizes, but a lot of people live on a half acre. Okay, so anyway, my point is that you guys, I have answers between 100 and 800. Nope, 900. All right, so we'll see who's right in a moment here. I'm going to average up what I saw to be about 400. I would say the average that you guys told me was about 400. Okay, so I just gave you everything you need to solve for the radius. The surface area of our can is 400. Write me an equation that could be solved. We aren't going to use the calculators today. I've decided we're just going to write the equations. Okay? Write me an equation that could be solved to find the radius. That means the answer is in terms of r. Or you could say x, but the x better be the radius. But this is a can that I already drew a picture. You already drew a picture of where the height is 3 times the radius. That is correct. All right. Word problems are a challenge, but if you use this method that I am showing you, I believe you will be successful. If you have the pure form of the formula, it's that. If you have a picture that is labeled, it should have looked something like this. Your artistic ability really doesn't matter that much. But we're going to call that R, and I would be totally fine if you would have called it X. But it's a little better to call it R, isn't it? Because then I know what it is. Otherwise, when I'm done, if I have X, I don't know if that was its height or if it was its width, its radius. Okay, so if that's R, then obviously this was 3R. Raise your hand if you had that. Okay, good. So next thing is to put the info that we now have from our labeled picture, which we think has a surface area of 400, and put that info into our equation. And you should have said 400 for the surface area equals 2 is still 2, pi is still pi, but r is still r squared plus 2 is still 2, pi is still pi, r is still r, but h cannot be just an h. Otherwise, your equation would not be in terms of r. So all I got to do is put in, instead of h, 3r. I hope you found that one to be easy, because that's about as easy as I can make it. Any questions on that one? You get it? If you solved that equation, you would have the answer for r. All right. How would you solve it? If I gave you a calculator, what would you do? Plug it in. Plug it into what? Y equals. Oh, good. So you would plug in y equals 400 equals blah, 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 blah. I'm playing dumb here. Yes. Y equals this, and y equals that. Graph this, graph that. And think about it. It's a parabola. What shape would it be? I like a U shape, right? Is it upside down or right side up? Is it like a U or a mountain? Like a U. So it's like this, and you graph it, and it looks something like this, and then it's got this line at y equals 400 going across like this. And do you get why this one would make no sense at all? Because what? You can't have a negatives for x, because x, in the context of this question, x or r, the radius can't be negative, so then this one must be it. And you just have to find where those cross. That's how you would solve it. We are not solving them today. We're just writing equations. All right, I'm going to give you one more that's like that to do by yourself before I put you in a group. Make sure that you are a capable group member for the people I put you with. Are you ready? This time, it's a box. And the box is about 4 times as long as it is high. Good question. Let's say I need my box to be able to hold about 80 cubic inches. 80 cubic inches. It's 4 times as long as it is high. One more thing. Its width or depth has got to be 8. Make it work for our marketing people. Yep. They want the box to be 8 inches deep. That way it fits on the shelves at Target or whatever. Got that constraint too. 4 times as long as it is high, and it's 8 inches deep. You should now have a nicely drawn picture with labeled with like little X's and stuff on the sides that are accurate to the situation. And then you should have a pure form of the formula involved. And then you should be sticking the numbers from the picture into the formula. Yes? Does it have to equal 80? Good question. I did say equals 80. But if we had changed it to less than or equal to, it would add a lot more complication because we have a range of answers. But that's a good point. Mr. SH, what do you think my box should be labeled with? I'm going to use different color sides so you can tell me, like, there's the red side, there's the green side, and then there's the blue side. Would be like that. It says 4x. All right. What is x? That makes me really curious which one you chose for x. Okay, you chose x for that. Okay, good. Then that makes sense because now it's 4 times the height. All right. And then? Or it should be 8. And they said we wanted the depth to be 8. Awesome. Then I need a pure form of the formula. Miss NA in the back. And start sticking in things we know. I'm going to call it X, but I do like the idea of calling it H. In fact, should I switch? Is there any reason that H is better than X? Yeah, there is. Because now I know that when I'm done, what I solved for was the height. Do you get what I'm saying? Otherwise, if I solve and I get x equals, you won't know if you have an answer that's a height, or if your answer is a width, or if your answer is the depth. So if I think I like your idea, we're going to go with an h for that. Okay, so length is what? 4h. Width is 8. And what's the volume actually supposed to equal? Could you solve that? Would it be a quadratic? If you multiply out the right-hand side, will there be a squared involved? Therefore, what shape will it be? A parabola. And now, is it very possible one of your answers might be extraneous? All right. And where the two equations cross is where you would find your answer. All right. Cool. I think that's enough practice. Now, I'm going to put you in groups to solve these questions. They are called Chapter 4 application problems, which makes no sense because we're in Chapter 7, but that's okay. They were in Chapter 4 of the previous edition of the book that we were based on, and so anyway, don't worry about it. There's some practice questions right here. They are going to need, and I know people don't believe me on this, you are visual beings. A picture helps so much. A picture is worth 1,000 words. On the ACT, if there isn't a picture drawn, you should draw one. So it really does help. Please draw a picture for every single one of these and label it. And then if you try to do it all with formulas, you get lost. And as soon as you show that kid who like comes up and goes, I can't see this one. As soon as they like draw the picture and I make them label the stuff, they're like, oh, I get it and I know what to do. So please start by drawing the picture, labeling it, and then pure form of the formula. All right. One more thing. I want you to know that other teachers are not teaching it exactly this way. They're saying it that you have a big formula and a small formula. This would be the, quote, big formula, and this would effectively be the small formula. But I think it's so powerful to have the picture there that I'm not doing it with a little formula and a big formula. I like the idea of having the picture be your smaller formula. Because you can't just draw a picture, really, can you? You have to draw it, and you have to like think how to label it, because really that becomes your second equation. And I think this way is very good. I've used it for many years, and it's worked well in regular pre-calc, and I can tell the problems are very similar in this case for honors pre-calc. So in case you hear people talking about the little formula and the big formula, the little formula is just the one that you had to make by having the picture. But I think being able to see it in a picture helps you so much on where to stick things in. Okay, so now on to the part in class, and that's all I have for the video for